Welcome back to our chapter 1 discussions all about limits and continuity. And this time we're going to talk about continuity on an interval. This is a continuation on our last topic. Our objectives are the following. The first one is to illustrate continuity of a function on an interval. Next, determine if a function is continuous from the right or from left at a number. Then determine whether a function is continuous on an interval or not, and illustrate the intermediate value theorem. These are the four objectives that we need to obtain and learned in this lesson. First, let us have this first definition. Definition 1.7.1, a function f is continuous on an open interval. Ang ilhanan sa open interval is this symbol. A function f is continuous on an open interval if and only if f is continuous at every number between a and b. Sa atong timanan ang term nga dapat si f is continuous siya sa tanang numero between, meaning mga numbers nga naa sa tunga or between sa A or sa B. For example, if RA is 3 and then RB is 9, so from 4, 5, 6, 7, 8, dapat continuous si F para makaingon ta nga F is continuous on an open interval AB. So kung balikon, continuous si F sa open interval if and only if ang F is continuous siya sa tanang numero between A and B. Defining continuity on an closed interval. So human nata sa open interval. Karon we have the closed interval. Ang symbol niya is kari. It represent as closed. Kay ang katong parenthesis, it represent open interval. On the other hand, poses a little challenge. For example, consider the function defined by f of x equals square root of 1 minus x squared. So, ito ni siyang hatagan og emphasis. Note that yung f is not continuous at negative 1. Since before nimo makuha si negative 1, you must find first the x approaches negative 1 from the left, and then x approaches negative 1 from the right. And then, dapat siya equal para mahimong continuous. Diba? But sad to say, in this given radicals or expression, the left, for example, that is the left of negative 1, what will happen if you need to substitute negative 1 here? So from the left of negative 1, we have negative 1.01, negative 1.5, and so on. We cannot determine the limit. Diba? Pero og x is approaches negative 1 from the right, we have negative 0.99, and so on, we can have the limit. Nya kay dire kay wa may limit, dire na limit, so automatic does not exist. Kaya dili man sila kapareha. That is according to the rule in our previous lesson. And also for x, which is approaches 1 from the left and approaches 1 from the right. Okay? 1 from the left and x approaches 1 from the right. Pag left of 1, so for example, 0.9, 0.5, may limit tayo using square root of 1 minus x squared. Pero pag greater than 1, 1.5, 1.01, we cannot have the limit. since magiging negative ang atong sud sa radical sign. Kay mahimong greater than 1. So 1 minus greater than, so we can have negative. So we cannot have the radical result if we have negative the inside. So still does not exist. So manaybot pasabot nga f is not continuous at negative 1 and 1. So we cannot say that f is continuous in a closed interval of negative 1 and 1 at that moment. So dili ta makaingon. Pero kung atong tan-aw ng graph here, so say makita nato diha, masabta nato nga matrace nato ang graph gikan sa negative 1 padung sa positive 1 without lifting our pen. Meaning, continuous siya ani nga side. Diba? Sa previous lesson nato, pag matrace gani nato ang graph without lifting our pen, meaning that is continuous. So they are continuous at the closed interval negative 1 to 1. So here. So to resolve such dilemma, we introduce the concept of continuity of a function from the right and from the left of a number. So we have the second definition. A function f is said to be continuous from the right at a if and only if limit of f of x as x approaches a from the right is equal to f of a. So, ang limit niya sa f of x as approaches x from the right of a, kapareha dapat siya sa f of a. And then, a function f is said to be continuous from the left at a if and only if limit of f of x as x approaches a from the left side is equal also to f of a. So, muna siya. Dapat magkapareha si f of x ug si f of a. So, we remark that a function f is continuous at a if and only if f is continuous from the right and from the left. We can now define continuity on a closed interval and a half-closed intervals. So, naatay closed interval o half-closed interval. So, take note ganina, ang open interval, basta continuous siya sa tanang numbers in between sa A o sa B, it's okay. So, they are continuous na. Pero here in the closed interval and a half, we have different situation. Here, we have the closed interval. A function f is continuous on a closed interval if and only if the following conditions are satisfied. So we have three conditions sa closed interval. Una, f is continuous on a open interval A and B. So dapat okay siya sa open interval and A and B. Pag dili okay, so automatic, dili na siya continuous on closed interval. Number 2, f is continuous from the right of A. And then also number 3, continuous should siya from the left at A. So aside from the continuous on an open interval A and B, dapat po continuous siya from the right at A and from the left at A. So that is the condition for closed interval. Next definition, a function f is continuous on a half-closed interval. This is closed interval or closed A, and we have the open. Half-closed interval, if and only if the following conditions are satisfied. Number 1, f is continuous on open interval AB. So the same as the closed interval. Since this is half-closed interval, kaning nga part sa A is closed, dapat continuous siya sa right at A. Ari nga side. Close naman, so this is the end. Padong dito. That is the right at A. The second one is continuous on a half-closed interval. So nakusob na pod. Sa side sa A, we have open. Here, we have the close. If f is continuous on open interval AB, and f is continuous from the left at B. From the left, so in this side. Amo na to timan-an para ma-determine nato kung continuous ba siya. We say that a function is continuous on open interval negative infinity and positive infinity, or the real number if it is continuous everywhere. So, pag continuous siya sa tanan, we can determine niya ang open interval is continuous. Continuity on the other unbounded intervals. Example, open interval negative infinity and b, half closed interval negative infinity and b. This is from the left of b. Then we have open interval a and positive infinity, and then half closed interval a and positive infinity. So from the right of a. So can we define intuitively and will not be given here. So we have some examples. The function defined by f of x is equal to square root of 1 minus x squared is continuous on open interval negative 1 and 1. So take note, kasi continuous na siya sa open interval negative 1 and 1, so the other also, they are continuous. Even closed interval, diba? Sa tuyo na nga condition, dapat continuous on an open interval negative 1 and a. And we have continuous from the right at a, and then from the left at a. That is the third definition, right? The right at a and left at a. And then for half closed interval, here, una is dapat continuous siya sa open interval. Okay siya dire. And then here from the left side, this is the second one. Dapat continuous siya diha. The next is continuous dapat siya una sa open interval negative 1 and 1, then continuous sad siya sa right sa negative 1. So let's have some examples. Consider the function g of x is equal to square root of x minus 1 if x is greater than 1. G of x equals 3 if x is equals 1. And then last is g of x equals 4 minus x squared if x is less than 1. Determine if g is continuous on each given interval. So we need to determine if our g of x is, or our g is continuous on each given interval. So we have the first one. Open interval 1 and 4. So meaning, pag sinabing open interval sa 1 and 4, may mo siyang continuous if, diba, first definition, dapat tanan number continuous siya sa in-between niya. So, in-between sa 1 and 4, we got 2 and 3. Here, we're going to use, is it x greater than 1, x equals 1, or x less than 1? So, ang in-between sa 1 and 4 is unsa man, in-between. So, this in-between 2, in between sa 1 and 4 is 2 and 3. So that is greater than, this one is greater than 1. So kanya to gamiton. So first, g of x equals square root of x minus 1. First is g of x is equal to 1. G of 1. So that is 1 minus 1. The answer is 0. And then next, find the limit of g of x as x approaches 1. So, dapat siya pareha siya dire sa iyang g of a. Diba? So, we have limit of x minus 1 as x approaches to 1. So, this is square root of 1 minus 1. The answer is 0. Since atong g of a is equivalent to our limit of g of x, which is 0, therefore, continuous si g sa open interval 1 and 4. So the next one, number 2, we have half closed interval 1 and 3. So take note, we have, this is from definition 1.7.4. A function f is continuous on a half-closed interval. We have the closed interval from A and open interval sa B if and only if the following conditions are satisfied. First is f is continuous on open interval A and B, and then f is continuous from the right at A. So here we need to satisfy those two conditions para ma-determine nato if this is continuous. And to find the limit of g of x and our g of a. So here our g of a is what? Is equivalent to our here x equals 1. That is our g of a. So our g of a equals to g of 1, which is equivalent to 3. And now we need to satisfy the given interval, half-closed interval 1 and 3. So, ang buhaton nato diri is to determine the right limit of 1, diba? From the right. O na nakabutang nato diri sa atong definition. Continuous from the right at A. So, our A here is 1. So, we got limit of g of x as x approaches 1 from the right. So meaning greater than 1, so we need to use limit of square root of x minus 1 as x approaches 1 from the right equals square root of limit x minus 1 as x approaches 1 from the right. So which is equivalent to square root of 1 minus 1, which is 0. And now, atong i-compare if our g of a is equivalent to our limit of g of x. So now we are going to compare if our g of a is equivalent or equal to our limit of g of x. So limit of g of x as x approaches 1 from the right, and then we have our g of a. So is it equivalent? So take note, our g of a is 3, value at 1. Since we have this closed. And then, our limit of g of x as x approaches 1 from the right is 0. So they are not equal. Therefore, this is not continuous. Okay? So therefore, g is not continuous on half-closed interval 1, 3. That is the difference between A, open interval 1 and 4, and we have the half-closed interval. So, atong gamitan ng mga given conditions para makuha nato ang exact ni answer. Next, we have letter C, open interval negative 1 and 1. It is different to open interval 1 and 4. So, when you say open interval negative 1 and 1, para makontinuo siya is dapat ang number in between negative 1 and 1 dapat continuous. So here asay gamito nato diri for example letter C. Here we have x is greater than 1, x equals 1, and x is less than 1. So what is in between negative 1 and 1? That is 0. And 0 is what? That is less than 1. So therefore, ang atong gamiton karon para makuha ang limit is g of x equals 4 minus x squared. Pag continuous gani siya, if there's a limit, then can say that is continuous on our G at open interval -1 and 1. So first we got limit of g of x as x approaches 1 from the left, which is equivalent to limit of 4 minus x squared as x approaches 1 from the left. Then, limit of 4 is 4 minus 1. We get 3. So that is x is less than 1. So next, our g of a. Our a is equivalent to 1. The answer is 3. So take note ang atong limit of g of x and the g of a is the same, which is 3. So g is continuous on open interval -1 and 1. Now next, we have letter D, the half closed interval. And karon ang close niya is in this side, which is I think the second one. Yeah, this is the second one definition of half closed interval. So we have the conditions. First is dapat ang f is continuous on open up interval of the given, and then continuous from the left at B. So we have open interval -1 and close interval 1. Is it continuous of open interval here? Yes, check the daan. As we know on our letter C, G is continuous on open interval -1 and 1. So now we need to find from the left of 1. So here from the left of 1, meaning gamay siya sa 1. So we need to use 4 minus x squared to find the limit. So first, our g of a is equal to, diba, 1 man, g of 1, which is equivalent to 3. And then we need to find our x is less than 1, or the limit of x from the left side. Limit of g of x as x approaches 1 from the left, which is equal to limit of 4 minus x squared as x approaches 1 from the left side. So we got 4 minus 1. So the answer is 3. Take note, our g of a is 3, and then our limit of g of x as x approaches 1 from the left is 3 also. So they are equal. Therefore, g is continuous on half closed interval -1 and 1. We have the last example, a half closed interval -2 and 5. So this is very different from the previous examples. Compared to the previous examples, we can see number 1, but here we cannot see number 1. But take note, we have this half closed interval, but from the left, we need to find here if this is continuous sa yung left side at RB, which is 5. And take note, 1 is in between -2 and 5. So, pwede ito siya magamit diri. So, take note, this half-closed interval, ang first nga condition is dapat siya continuous on every number in between ani. Since that is the first condition here, f is continuous on open interval AB. And take note, 1 is appeal si 1 sa in between sa -2 and 5. So, take note, if appeal si 1, so atong g of a, which is ang a equals 1 rather, get 3. And then we need to find now the limit. So we can have the greater or from the left and from the right. So we got limit of g of x as x approaches 1 from the right, which is equivalent to limit of square root of x minus 1 as x approaches 1 from the right, square root of limit of x minus 1 as x approaches 1 from the right. So that is equivalent to square root of 1 minus 1 equals 0. And limit of g of x as x approaches 1 from the left, which is equal to limit of 4 minus x squared as x approaches 1 from the left, equivalent to 4 minus 1, which is 3. And take note, our limits from the right, which is 0, from the left is 3, is not equal, therefore does not exist. So limit does not exist kaya di man siya kapareha. Automatic, G is not continuous on half-closed interval -2 and 5. So ato lamang timan-an ang mga conditions. And take note, ang open interval sa A and B is very important to determine first. If hindi siya continuous, automatic yung mga half-closed that is not continuous on a certain given interval. If a function is continuous on a closed interval, so na sabton, kung ang function ko no continuous on a closed interval, and the values of the function at the endpoints of that interval are not the same, then there is a theorem that ensures that for any number k between the values of the function at the endpoints, we can find a number in the interval whose function value is k. There is a theorem, which is what we call intermediate value theorem or IVT. And this intermediate value theorem is very important. It has an important role in the development of calculus. This is the definition. Intermediate value theorem. Let a function f be continuous on the closed and bounded interval. So this is only applicable for closed and bounded interval. We have it here. Closed and bounded interval AB. Where our f of a, take note, ang f of a is not equal to f of b. So yung endpoints dili magkapareha. Then for any number k, the number k that is in between f of a and f of b. Hindi kang a and b, kundi their f of a and f of b. There is at least one number c, saka number nga, which is c, that is an element of a and b. The closed and bounded interval a and b, such that the f of c, which is the c, is equal to k. So to make it clear, we have this illustration. Figure 1.7.2. On the right shows the function f, which is continuous on the closed interval a and b, with f of a kana and f of b. Take note that our f of a is mas dako kaysa sa our f of b. This is our f of a. Ang f of b is kare. So, meaning, mas dako si f of a. F of a is greater than f of b. Notice that for a specific value k, here, between f of a and f of b, there are three values in the closed and bounded interval AB with a property that C sub 1, C sub 2, and C sub 3. That is our f of c sub 1, f of c sub 2, f of c sub 3, which is equal to k. Kapriya lang sila. So let's have some examples. Let f of x is equal to the cube root of x minus 3 plus 1. Determine if IVT applies to f on the closed interval 4, 6 for k equals 9. If it does, find a number c that satisfy the theorem. Duha atong pangitaon. Number 1 is you need to determine the IVT. And on the closed interval 4 and 6 for k equals 9. Kung meron, then we need to find the number c. To determine the IVT, we need to satisfy two conditions. Number 1, our f must be continuous sa atong closed bounded interval or closed interval 4 and 6. And then ikaduha, our k, which is equal to 9, must be in between our f of 4 and f of 6. So, mana atong duha ka conditions nga atong i-meet to determine the IVT. Since our f, which is the cube root of x minus 3 plus 1, is a polynomial function, it is continuous at every real number. So, bisan unsa pa nga real number imo ibutang diri, continuous siya. So, therefore, our f is continuous. Satisfied na ta sa atong first nga condition nga ang f must be continuous sa closed interval 4 and 6. Atong problemahon karon is kanina lamang the second one. So first identify the f of 4. F of 4. So we got cube root of x minus 3 plus 1, which is equivalent to 4 minus 3, cube root of 3 plus 1. So we got 1 plus 1 equals 2. And then f of 6 is equal to the cube root of x minus 3 plus 1 equals the cube root of 6 minus 3 plus 1 is equivalent to 3 cubed plus 1. So that is 28. So is it 9 in between sa 2 and 28? The answer is yes. Ang condition dapat is si k in between siya sa f of 4, which is 2, and f of 6, is 28. So our k is 9, meaning in between siya. So we have the existing IVT. So there is IVT for our f. Next, if mayroon daw IVT, find a number c. So take note, our c, according sa definition, must be an element of closed interval 4 and 6. Right? Such that our f of c is equal to 9. So ang c na to, dapat element siya sa 4 and 6. So f of c must na equivalent siya sa 9. We need to find the value of c. From here, f of c is equal to c, the cube root of c minus 3 plus 1. And our f of c is 9. We need to find the value of c. So this is 8 na. Using the subtraction property of equality, so we got 9 minus 1, 8. Ang remaining here is only what? A cube root of c minus 3. And then, can remove that one. Cube root sa na nato. So we get 2 of c minus 3. Get 2 plus 3 here. And we have c. Therefore, our C is equivalent to 5. In this problem, we know that there is IVT and find a number C. Our C is 5. That's it for our IVT. That is continuity on an interval. So the same as our previous lesson, we need to familiarize the given conditions and apply the past lesson to this present lesson so that we can connect and understand limits and continuity.